Hello everyone, and this is not physics. In all of my physics videos, I started that particular video with "This is physics." I used this exact piece of paper right here. But right now I have retired from physics, so this particular video is not physics. Although I still have the textbooks of my times as a physics professor, as well as my jacket. In this video, this is a little bit of woodworking. I like to call it Woodworking 101, but I'm not a trained woodworker, so I'll call this Woodworking 100. Maybe at the end of this project I can graduate myself to Woodworking 101, but in the meantime it's just going to be, let's see what I have here, a little bit of woodworking, and I'll throw in a little bit of physics where I can, a little bit of mathematics, definitely some metrology, because well, you can't build anything without a measurement. So without further ado, let's have a look at the project that I'm going to do for this video. I was asked by a family member if I can build one or both of these trees. She sent me this picture. Well, let's have a closer look. It seems to be just simple 2x4 construction. A little bit of staining at the end. And there are two of them. This taller one in the background and this shorter one here in the foreground. And I said to myself, as a woodworker 1000, I ought to have the skills enough in order to build this simple construction. And so in this video, I'm going to make this tree back here. And I thought to myself, what you need to do right now is print a picture and then remove these decorations and have a look at the construction of the tree itself. And so that's what I did. I printed this picture and I removed these decorations, and let's have a look at what I came up with. I printed a picture of the two trees. Now what I need to do is trace this out on a blank piece of paper. I just put a blank piece of paper on top, held it up against the light, and traced out the actual tree itself. There's different ways to do this, but I just took the simple route. And this is what I get. Here is the picture. I had it printed, and I drew a sketch of the outline. Here it is. What I needed to determine was these two angles. I already wrote down 70, but here's what I did. I put my protractor on here. Bring you a little bit closer. And this angle, according to my sketch, is just about at 70. There's 70 degrees, sweeping from the 0 upward to about almost 70. And doing on the other side, similar thing. Sweeping from the left, and this one's about 75, well, obviously, coming from picture. So if I were to look at the picture itself, and try and measure this angle, assuming the picture was taken directly on, and it's about going a little shy of 70. So I'm going to use 70 degrees as this angle here, and the same with the other side. This makes this basically an isosceles triangle. Looking at the actual construction, we see down here this leaf and this leaf right here actually rest on the base, whereas on the smaller tree, the leaf here is adjacent to the base. Here's the base, and you notice the leaf is next to the base. I like this construction, but I'm going to make a slight modification to it. So it looks like this. Here we go. I'm going to extend the leaf a little bit below the base. I'm going to make it adjacent to the base. There's going to be a stand here. And I'm going to make this protrude about a ½ an inch below the base. We know that this angle is 70 degrees, and this angle is going to be 70 degrees. What I need to calculate now is the length of this base right here. And we'll do that next. As I said, I was going to make this a little bit longer. One of the reasons I do this is for water. As water comes down, it's going to drip, fall on here, and then drip down. In the other construction, water will come down here and seep underneath. So to avoid that, we'll just make it drip down, because this I expect will be outside. Having said that, let's have a look at the length of this base. What we have here is a triangle. There we go. We've decided, or I should say, we have decided that the height of this triangle, the height of this tree is going to be 24 inches. That's this height right here. This angle we know is going to be 70 degrees. If I redraw this, it becomes a right angle triangle. This is 90 degrees. Here's the hypotenuse. And this one here is 70 degrees. And I know this height is going to be 24 inches. What I need to find is this one. This will be the adjacent. Here's the angle. This is the opposite to the angle. This is adjacent to the known angle, and we have the hypotenuse opposite the right angle. To solve this, we're going to use a little bit of trig. I'm going to use SOHCAHTOA. Sine is equal to opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent is opposite divided by the adjacent. And I don't have the hypotenuse. I don't know what the hypotenuse is. But I do have this one. So I'm going to use tan of 70 degrees is equal to the opposite divided by the adjacent. And that is equal to, I know what the opposite is 24 inches. And I need to find the adjacent. Making this simpler, this tan of 70 degrees is equal to 24 inches divided by the adjacent. Rearranging this such that the adjacent, which is what we're looking for, that length is equal to 24 inches divided by tan of 70 degrees. And that comes to, here we go. 24 divided by the tangent of 70 degrees, 8.7 inches. So we'll round this down to 8.5 inches. That means I need to have that length here to be 8.5 inches. So in the actual triangle itself, or the tree itself, it's 8.5 here and 8.5 there. Times 2. Add these up. 10 carry 1, 16, 17 inches. So from this tip to this tip, I want it to be 17 inches. This ought to give me a height, overall height here of 24 inches. Using my paper 2x4s, let's start building the base. And we said it was going to be, what did we say? 17 inches. So I have this measuring tape here at 17 inches. I'm going to stretch this out to 17 inches. bit more. So this is about 17 inches for the base. Seems to be a little long to me, because not only am I going to have this for the base, I'm also going to put the 2x4 out the side here. And that'll be add an extra 1.5 inch width. So instead of doing 17 inches, I'm going to reduce this down. We'll take an inch off either side. So reduce this down to 15 inches overall length, such that the tree doesn't become too bulky. 15 inches. Right about here. So this will be the length of our base, and then there will be one of the leaves will be on the outside of it here. So let's put this together. I have some tape. I can put this together. This will represent the 2x4 along the base, and it's the length of this base here that which will determine the overall height. Now we also want this angle here to be 70 degrees. The thing about a table saw, or even a miter saw, they have tilts on the blades, and those blades will only go from 0 to 45 degrees. But I need 70 degrees. Well, that's not going to happen, so I'm going to have to find another way to cut this such that I get a 70-degree angle. Let's go a little closer here, right to the edge. Here's my protractor. And I need this angle here to be 70 degrees, so starting on the left to 70. Here's the 70 mark. Yeah, just go a little bit closer yet. And overall it's 90. So a table saw will do 20 degrees. So if I sweep in 20 degrees from that face, right here, and if I do the same on the other side, and I want to set up my equipment, table saw or miter saw, depending on which one I'm going to use, to 20-degree angle, as long as I cut from that edge inward, 20 degrees. So let's cut this. It's easier to use paper than it is to go cutting wood. So I can make a model. Yeah, let's do that again. So this will be my base. Bring you back down. And this angle right here ought to be 70 degrees. There it is, 70 degrees. To match my little sketch. This angle right here, 70 degrees. But I know I'm going to have to cut 20 degrees on my equipment. So this will be my base. On the side of the base will also be 2x4s attached like this. And I'm going to go ahead and construct the rest of this tree using my paper 2x4s. Here is my 2x4 paper construction of the tree. Let's take a closer look. I need a measuring tape. And I'm going to make, well, the bottom length, as we said, was going to be 15 inches from tip to tip. Here, 12, 13, 14. There we go, 15 inches tip to tip. And I decided to make the lengths of these for my mock-up 12 inches. So this is 12 inches long. This made this one also 12 inches long. That's going to be 12 inches, a little bit shorter. 12 inches here as well as this one. So if we look at this overall, I have 12 inches or 1 foot, 2 feet, 3 feet, 4 feet, 5 feet, 6 feet. And this one here is about 1.5 feet, 15 inches. So that's 7 feet and a little bit. So overall, this will require a 2 by 4 by 8 foot length. So 2 by 4 by 8 feet ought to be able to make this tree. Now I can go to the lumber yard and pick up a piece of 2 by 4 by 8 feet. I moved to my workshop, and here is the mock-up tree that I made. Each one of these will be 12 inches or 1 foot, so I'll need 1, 2, 3, 4, 5, 6 pieces at 12 feet plus that one at the bottom at 15 inches. Here is the 2 by 4 that I bought. And I've marked off 12 inches, make sure everything is going to work. So there's 1, there's 2, there's 3, here is 4, here is 5, and 6. And what's left over to make that 15-inch piece. I have set up my miter saw in order to make these 12-inch cuts. And I moved my marks over just a teeny bit in order to allow for the kerf being the thickness of the blade itself. And I will do all of this off camera. And here they are, 6 pieces, 1 base, and one whopping mess to clean up. There, it's virtually everywhere. Here are my pieces. What I'm going to do next is here on my joiner. This is a 6-inch joiner. It's got 3 blades, 3 linear blades. I'm going to run it through my joiner to remove all this writing and smooth out the surface as well. And I'll have to do that to all 4 sides. 1, 2, 3, 4. And again, I'll do all this cleanup here off camera. I did a dry mock-up. The base right here is now cut to length with the 20-degree cut, giving me a 70-degree angle. This protractor here is set at 70 degrees. So you can see I've got 70-degree inside angle there, 70 degrees inside angle here with a 20-degree cut on my miter saw. A little bit of overhang as I planned. Going on up. I need to calculate exactly how much overlap I want to put on these. This one here has a little bit more and that one's a little bit less. But I'll work on that. And up to the top, I'm going to have to do some work up here so everything matches. Otherwise, yeah, it's looking really good. The overall length, right, from that inside up to, well, at the top of the 2 by 4 is 26 inches. Remember, we calculated 24, but then again, I'm also staggering these outward, giving me more height, rather than having a straight line from here all the way to the top. So I've added a couple of inches by doing that. Still, 26 inches from the tip there down to here is still good. I set up my miter saw to do a 20-degree cut. Here is the 90, and I moved it over 20 degrees. I did a sample piece. Here it is here. And you can see on the laser how it's set at an angle. If I turn this around, there's my reference, and there's my 20-degree angle. So I've gone ahead and cut several boards. You can see them here. There's a 20-degree cut and 20 degrees here. A little bit of overhang like I discussed earlier. Now I need to go ahead and cut my 20 degrees up here and this board and that board all the way up. And well, I'm going to have to leave this one till the end. Otherwise, all going good. The four corners are a little bit sharp, so I'm going to use my round over bit here on my router and round over the corners, all four sides. And again, I will simply do that off camera. Here are some of the pieces. They're ready for sanding, but before I do any sanding, I'm going to do a little bit of water treatment just to raise the grain. I'll put some water on a sponge. Then dab the wood pieces with the sponge, get them a little just damp, and then let them dry, like so. That'll raise the grain, and then I'll do the sanding. Here's the project. It's almost complete. I just have to give it a varathane on the surface. I have stained it, and I used early American stain. I'm using up what I have left over from past projects. And it looks good. I like this color, early American, to represent a tree. Couple of things to note if you're going to build something like this. Down at the bottom here, I put in plugs. And the plugs, well, they're slightly noticeable. I chose not to put in the plugs here for the rest of the construction. I just put in screws, and I countersunk the screws, and I just left them open like that. So you can go either way. Another thing of note, when you do the staining, the end grain, well, you can see it here on the top more than anywhere else, the end grain will stain darker than the flat surface of the wood itself. That's normal. But if you're going to paint this rather than stain, then you can put plugs here and plugs all the way around, hide all the screws, and the paint then will hide the plugs. Nobody will know the difference. So it'll look good painted. It also looks good stained, but it has a couple of complications with regards to stain. Another thing, should you want to build something like this, I do have glue between the boards, but you got to watch out for glue squeeze out, because the glue itself will not stain. So you got to avoid any squeeze out of glue. Keep this glue inside or between the boards. There's a couple of places here where I did get a little bit of squeeze out. I knew about this, so I put in as minimal as I could. Hence the reason I had to use the screws, because I didn't use as much glue as I should have in order to give this good strength. So I put in the screws in order to supplement the little bit of glue that is in here. But I tried to avoid glue squeeze out, such that it doesn't show up, because it literally won't stain. That is the other problem here with the plugs as well. Try to use minimum glue on the plugs, such that you don't get the squeeze out, and it won't show a ring around. Other than that, it's looking good. It's a good project to build if you want to build one. I will show you what the actual dimensions are in a couple of minutes. To do a short recap, here's a picture of what I was given, and I was asked to make this tree. From that picture, I come up with this design. And here is the final product. I took the actual measurements of the boards that I made. And the base, I decided to, in the final product that I chose to make it 14 inches. The two side leaves here are 12 inches. Here they're 12 inches long. Here's where I made an error in my original design. This length here is 13.5 inches long from this tip to that tip. And this length from this tip to that tip, after doing the cuts, is 16 inches long. This angle up here is 45 degrees with respect to that surface. This is the edge of the 2x4. Cut in 45 degrees to make that one. And for this surface here, that angle, it's also 45 degrees. Here is a picture of the 2x4. Here is the end of the 2x4 swinging inward 45 degrees to make this cut. For all of these, Down here, it's all at 20 degrees. 20 degrees for this one with respect to, well, there's how the 2x4 will look. So swing inward from the end of the 2x4 20 degrees, and we'll have this cut such that everything is horizontal to the base. I put in a 1/4 inch drop here, and there's a 2-inch overlap between the boards. Doing a summation of all the lengths, it comes to 0.5 inches. If I were to add in the kerf, which is the thickness of the saw blade, which is lost, it'd probably come to 101 inches overall length. So to build this, should you choose to want to build one, you'll need a 2x4 by 8 feet, which is 96 inches, but you'll need 101 inches, so you're most likely going to need two 2x4s. You need two 2x4 by 8 feet. 2x4 inches by 8 feet long.